Welcome to the next session of ANSYS Workbench tutorials. In this session, we are analyzing a truss bridge for transient structural analysis. We will start by double-clicking on transient structural. We'll go to engineering data. Here you can see the default material is structural steel. I will leave the material to structural steel itself. If required, you can change this data to any other material by going to engineering data sources, general materials. You can find list of materials over here and you can choose whichever material is required. We'll now go to projects, and if you have chosen some another material apart from structural steel, you need to update the project or else it is already added into the project. So next we'll go to geometry, right click, new design modular geometry, units millimeter, XY, look at. We'll go to sketching and choose polyline. Next I'll choose line. I'll go to constraint and choose vertical. Next I'll go to dimensions and give dimension to this line. Say it is 100. This vertical line, say I make it to 35. Say this is 50. Now this line you can see it is not up to the end. So I will just go to extend, and you can see it can be dragged up to the next endpoint. So dimensioning is done. Next I'll go to concept, lines from sketches. I'll choose the sketch 1, apply, generate. Next I'll go to concept, cross section. See, I give circular cross section and this dimension is 0.5 mm. I'll go to one part, one body, line body, and I'll choose the cross section as circular. So this completes the geometry. Next, I'll go to model and double click on it. Go to mesh first, relevant center. I'll choose sizing as fine and update. You can see here clearly the truss bridge has circular cross section. This is seen as 3D, but it is actually a 2D body itself. It's a line body. You can see in geometry, it's a line body. Next, we'll go to analysis settings, and I'm going to insert some boundary conditions. I'm going to insert fixed support at this end. At this point also I will insert fixed support. Now you can look very carefully. There are three more points at the center. Now suppose if a vehicle enters on this truss bridge. Now I am starting the analysis at this point, the first point at say 0 second. It will reach the second point at 0.5 second, and at this point say it is reaching at 1 second. You can start by assuming the fixed end as 0, 0.5, 1, 1.5, 2. So I will go for analysis settings and insert force. The force here is going to change with respect to time, and hence it is transient structural analysis. I'll define by component. The force will be along y-axis. So let me change this to tabular. At 0 second, the force will be say 5 Newton. At 0.5 second, the value will be 0, and at 1 second will be 0, which means at 0 second the vehicle will be here. Next I am going to insert another force at this point. I'll change vector to component. At this point I am applying in y direction a tabular data. At 0 second it will be 0 load. At 0.5 second the load will be 5 Newton, and again at 1 second the load will be 0. And at this last point I am going to insert force. I'll change vector to component again. Y-axis data is tabular. At 0 second the value is 0. At 1 second the value is 5. And at 0.5 second it should be 0. So if you look carefully, at the first point it is 500. At the second point it is 050. And at the last end it is 005. Now you can see the direction of force, it is showing upwards. I want the direction to be downwards, so I'll just attach a negative sign here. So you can see the direction has changed. Accordingly change it for force 2 and force 1. So I've applied the boundary conditions. I'll go to analysis settings. Since it is a time dependent response, I will give the end step time as 1 second itself, and the initial step time, say it is 0.01 second. Say the minimum step time is 0.01 second, and the maximum step time is going to be 1 second. Now I'm giving this value because the auto time stepping is on. In case you switch it off, this is not required. You will have to give data over here as to how many steps are required for getting the answer. So I'm using this option over here. Next I'll go to solution and insert deformation total. Also I will insert deformation directional. I want to see the deformation along the y-axis. I'll insert beam tool results, bending moment. Say I want to see the bending moment of the beam, and I want to see the stress. So I'll go to beam tool. You can see here the direct stress, minimum and maximum combined stresses can be seen. Combined stresses are an effect of bending stress and compressive stress at these points. Now I'll go to solution and solve. This is the total deformation. I'll just uncheck the minimum value. So I'm getting a graph of the deformation versus time. I can animate and check the results. You can see here at the first point the load is applied, and then at the middle point, and then at the third point. So that is how you see the effect over the bridge. Next you can see here it is the directional deformation. Now I'll uncheck this maximum value, and you can see here this is the deformation versus the time value. Again you can animate and check this result. This is the directional deformation along the y-axis. So you are particularly getting the result of bending moment over the truss. You can again uncheck the minimum value. You can see a graph here. This is the graph of bending moment versus time. All these values are varying with respect to time because it is a transient structure analysis. If you recollect in static structure analysis, which we have done using the same truss, at that time you are getting only one value of bending moment at a particular point over the truss. Here towards the right is the tabular data. You can see for various time intervals you have got the values of bending moment. You can just right click, select all, and then right click again and export this data and save it in case you require the data. Next we'll go to the beam tool result. We can see the result of direct stress over the beam tool. Direct stress means when the vehicle is moving fast over the bridge, you can see the effect of its load on the bridge. So we can just uncheck this minimum value and you can see here, this is the effect of the stress over the bridge. With respect to time, it is changing. Again, you can animate and check your result. This is the minimum combined stress and this is the maximum combined stress over the truss. With this, I end the session. I hope you have understood how to analyze a truss for transient structural analysis. If you have any doubts, please write to me in the comment section. Don't forget to like, share and subscribe to the channel. Hit the bell icon for latest video updates. See you in the next session. Thank you.